a single conversation burned 14,000 tool calls and $4,200 in OpenAI spend. The culprit, maxIterations, was set to 0 during development and never changed back. The article mentions summarizing after 8,000 tokens, but doesn't show the summarization function. Here's a concrete implementation that uses a cheaper model to compress history and stores the summary in Supabase. The article warns about infinite loops but doesn't show a deduplication pattern. Add a simple in-memory cache, or RIDIs in production, that tracks recent tool calls and returns an already seen message to break the loop. This prevents the agent from repeating the same tool call with identical arguments. The article shows streaming with stream text, but doesn't integrate token tracking per iteration. Here's a pattern that wraps the agent stream to log token usage and enforce a per-request token budget, returning an early stop if exceeded. Let's break down how to build an AI agent with Next.js, LangChain, and Supabase, how it works, and the exact mistake behind that failure. An AI agent is a smart assistant with a toolbox. Instead of just answering questions, it decides which tool to use, calls it, observes the result, and repeats until it has enough information. LangChain manages this loop, Supabase stores conversation history and vector embeddings, and Next.js streams responses to the user. An agent has 4 components that work together in a loop. The LLM decides which tool to call, the tool executes, the result is stored in memory, and the loop repeats. The agent executor orchestrates this cycle until a final answer is reached or a limit is hit. Let's look at the code. We initialize the LLM with chat-OpenAI, define tools with dynamic structured tool, set up memory with Supabase chat message history, and create the agent with create tool calling agent. Here we set up the LLM with GPT-4o and a deterministic temperature for reliable tool calling. Then we define a tool with a name, description, and ZOD schema for input validation. Memory is created using Supabase chat message history, which stores messages in a Supabase table. The agent is created with create tool calling agent and wrapped with runnable with message history to inject conversation history automatically. Supabase provides 3 key tables: conversations for session tracking, messages for history, and documents for vector search. The match documents function performs cosine similarity search. Here's the full SQL schema. We enable pgvector, create tables for conversations, messages, and documents, and define the match documents function for semantic search. Next.js integrates with the Versal AI software development kit for streaming. The root handler uses stream text to send tokens to the client, while the client uses the useChat hook to display them. For background processing, server actions run the agent synchronously. The client component uses the useChat hook from the Versal AI software development kit. It manages the message list, handles input, and displays streaming tokens as they arrive. For background processing, we use a server action. It stores the user message, invokes the agent, stores the response, and returns the result. No streaming, the user waits for the full response. Tools are the agent's capabilities. Each tool needs a clear description so the LLM knows when to use it, ZOD validation to catch hallucinated inputs, and actionable error messages so the agent can recover. A well-designed tool includes a detailed description that tells the LLM when not to use it, ZOD validation with min, max constraints and descriptions for each field, and deduplication logic to prevent repeated calls. This is the same issue we highlighted at the start. Here's exactly why that happened. The agent had no maxIterations limit. When a tool returned empty results, the agent retried the same query repeatedly, generating 14,000 LLM calls and costing $4,200 before the user canceled. The agent loop had no maxIterations limit, allowing the LLM to call tools indefinitely. This caused 14,000 tool calls and $4,200 in OpenAI spend in a single session. The fix is simple. Set maxIterations to a reasonable limit like 10, wrap tool calls in try-catch, and return a clear no data message so the agent knows not to retry. Also log iteration count to monitor for loops. Without deduplication, the agent can call the same tool with the same arguments multiple times. This wastes tokens and can lead to infinite loops if the tool returns the same result each time. Without maxIterations, the agent can loop infinitely, calling tools and burning tokens until you manually stop it or hit your API budget. Without rate limiting, a single user can send hundreds of requests per minute, each triggering expensive agent loops. Implement rate limiting with upstash or similar to prevent abuse. Token costs are the primary production concern. 3 strategies control spend. Conversation summarization reduces history size by 80–90%, model selection uses cheaper models for simple tasks, and token budgets enforce hard limits per conversation. This code shows how to retrieve conversation history with summarization. It loads the latest summary, then fetches recent messages up to a token limit. The checkTokenBudget function enforces a per-conversation limit and triggers summarization when exceeded. Production deployment requires handling Vercel's timeout limits, using edge runtime for long-running agents, implementing rate limiting, and setting up health checks to verify dependencies are available. Here we implement rate limiting with upstash 10 requests per minute per IP. The error handling wrapper logs every agent run with duration and status, returning a user-friendly error message on failure. To debug agent issues, log iteration count and token usage per session. Test with a low maxIterations like 3 to catch loops early. Use npm lszod to check for duplicate versions that can cause schema validation issues. Let's run through some common interview questions. What is an AI agent loop? A recursive LLM tool cycle that repeats until a final answer or limit. How do you control costs? Summarization, model selection, token budgets, and maxIterations. What causes infinite loops? Missing maxIterations, tools returning empty results, no deduplication. And a few frequently asked questions. What is maxIterations? Maximum number of LLM calls per agent run. How does Supabase help? Stores conversation history and vector embeddings for memory. Why use streaming? Reduces perceived latency by showing tokens as they're generated. Let's recap the key takeaways. Always set maxIterations on agents. Validate tool inputs with Zod. Summarize long conversations. Rate limit and monitor costs. Ready to go deeper? Up next. Next.js 16 caching strategies explained. The 2026 guide, then Prisma ORM best practices with Next.js 16 in 2026, then server actions versus TRPC in 2026, when to use which, and building production-grade AI features in Next.js 16. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.